earlier, so I updated it, so we're gonna hope that it is fine now, but we'll see what happens. All right, P5, solving equations graphically, numerically, and algebraically. We're not really doing anything with the graphically part because you can just graph something on your calculator to do that. So kind of just skip that for the moment. All right, solve the equation by extracting square roots. So number 8, we have 2 times x minus 5 squared equals 17. So when I do this, I'm obviously trying to get x by itself. So first thing I need to do is divide by 2. So I'm going to have x minus 5 squared equals 17 over 2. Now, if I need to undo a square, what do I have to do? And when I do that, what am I going to get?
X minus 5 equals the square root of 17 over 2.
I'm missing a very important thing.
Square root of, or plus or minus.
Plus or minus, there we go.
Remember we couldn't figure that out and we didn't get a cookie?
Yeah.
I remember that.
Yes.
It's not zero points.
So then add the 5 over, so x equals 5 plus or minus the square root of 17 over 2. And normally, obviously, we don't want to leave something with a radical on the bottom, but you could also rewrite this as x equals 5 plus or minus the square root of 8.5, and then you don't have to worry about that part. So if you left it this way for the sake of just solving, I would not take off for leaving the radical on the bottom, but just know in general we can't have a radical on the bottom. And also note that if this was a perfect square, so something like if this had come out to be like the square root of 16, which was 4, we would have 2 separate problems because we would have 5 plus 4 and 5 minus 4 to give us 2 separate answers. So just be aware of that also. 12, we have in parentheses 2x plus 3. It is being squared and is equal to 169. So what's my first step?
Take the square root.
And that's going to give me what?
X plus 3 equals the 8 plus or minus the square root of 160. Is that correct?
Let's say, is 169 a perfect square? Of what? 13. So this is going to be where I need to split it into 2 separate things because it's something that is a perfect square. So 2x plus 3 equals 13, or 2x plus 3 equals negative 13. And the reason we write the or is because x can't be 2 things at the same time, right? So the same problem. So then I'm going to get 2x equals 10. So x equals 5, or on the other problem, 2x equals negative 16, so x equals negative 8. And those two would be my answers on that. All right, the next thing, everyone's probably least favorite, completing the square. We have x squared plus 5x minus 9
Why would your English break
equals 0. Now remember, even if this was something I could factor, it said I have to complete the square, so I have to do it that way. So my first step for completing the square is I need to move this number over here. I have to move the constant term over to the other side. So I'll have x squared plus 5x equals 9. Then to complete the square, I'm trying to find the term that will give me a perfect square trinomial. So I add a box over here, but what I do to one side, I have to do to the other. So I put a box over here. What's the catchphrase for completing the square? It's like 4 or 5 words, depending on how you say it.
Remember opposite pay? Did you use the last word?
Starts with half. Half the middle term squared. So I take half of this, so 5 halves, and I square it. And what I do over here, I have to do over here. I usually write this side with the square on it because of doing a perfect square trinomial, but over here I usually go ahead and multiply it out, so I'll have 25 over 4 on this side. So then what does this factor into on this side now? It's perfect square trinomial. It's a good start.
Oh, plus. Or is it
5 halves.
2?
It's literally the first term and the last term, whatever the sign of the middle term is, and squared. Equals, over here I can rewrite this as 36 over 4, which would be the same as 9, plus 25 over 4. So x plus 5 halves squared equals, what was that, 61 over 4. So now it's just back to the stuff we were just doing. Take the square root of both sides. So x plus 5 halves equals plus or minus the square root of 61 over 4. Now with this one, we have a number on the bottom that is a perfect square, so I am going to rewrite this one as, on this side, plus or minus the square root of 61 over 2. And then I just need to move that 5 halves over. So x equals negative 5 halves plus or minus the square root of 61 over 2. Another thing to remember with completing the square is that the number in front up here has to be a 1. So this has to be a 1. If it's anything other than that, we cannot complete the square. It only works if there's a 1 there. Let's look at another one. 16. I've got 4 minus 6x equals x squared. And I'm still completing the squares that the instructions tell me to do. So what might I need to do first? Do what?
Get them all.
Move the 6x over.
So I'm going to move this 6x over because I need to have the constant term on the opposite side. So I'm going to have 4 equals x squared plus 6x. Now I can add my box to both sides. So what goes in the box this time?
6 over 2
So
squared.
3 squared. And then over here I'm going to write it as 9 instead. I just do that so that it's easier. A lot of people will go ahead and write this as 9, but I think it's easier to just write it as 3 squared since you're getting ready to factor it anyways. So on this side I've got 13. What does this factor into on this side?
X plus 3 squared.
X plus 3 squared. Now what?
Square root of 13 plus or minus the square root of 13 equals x plus 3.
Yep. So we did the plus or minus when we took the square root, and then x plus 3, and so ultimately we're going to have that x is equal to negative 3 plus or minus the square root of 13. And since the x was on the right side, if you had left it on the right side, that would have been fine. I just flipped the whole thing just because I like the x on the left. Any questions on those ones? All right, then one more. Solve the equation using the quadratic formula. So 20, we have 2x squared minus 3x plus 1 equals 0. What is my formula for the, or like what is my quadratic formula?
X.
Isn't it? X equals what?
I mean, yes, it's x equals, but I'm not writing that part, just the formula itself.
Isn't it b squared?
It's
Negative. Oh yeah, negative b
plus
plus or minus square root of b squared plus 4ac
minus 4
Oh, minus 4ac
over 2a.
Let's
Yep.
go. It's so good.
All right, so you do need to know that formula for your next quiz and also for the test. So if you don't know it, make sure you memorize it. You will need it. So now, just as a refresher, y'all probably, I'm quite 100% sure you've seen this before, but A, B, and C. So we're plugging in the numbers. It's critical that you realize that if there's a negative in front of the number in this equation up here, it has to stay with it. So like for B, the B value is actually negative 3. Some people get tempted to just write 3 and they're like, oh, signs don't matter, but they do. So when I plug this into the equation, I'm going to get negative b, so that, or I say negative b. Negative times negative 3, so that's going to be a positive 3, plus or minus the square root of negative 3 squared minus 4 times 2 times 1 all over 2 times 2. So I'm going to then get 3 plus or minus the square root of 9 minus 8 all over 4. So that's just the square root of 1, which is what? 1. I was hoping I wasn't going to trick anybody there. So I'm going to go ahead and split it. So 3 plus 1 over 4 or 3 minus 1 over 4 gives us 1 or 2. I was about to write 2/4, 1/2. So x equals 1 or x equals 1/2. Are we okay on quadratic formula? All right. Then, that being said, problems 5. Nope, I lied, not 5. 9, 11. I'm going to tell you 11 is with y's instead of x's, but it works the exact same way as long as with x's, so just don't let that like throw you off. 13, 17, that's going to be a little bit of a challenge problem, but you should be able to do it. And then 21. And then 47 and 51, we obviously didn't do one that far down in the problems, but that's because it says to use a method of your choice to solve the equation, so you can pick through your repertoire of methods that you have and see which one works. Obviously, there are certain occasions where certain things don't work. If you can factor, factor. If factoring doesn't work, then try completing the square, or try by extracting square roots, or whatever the case may be, to solve those two. But that's all your problems. And you do need P6 notes for tomorrow, which I think might be a little bit long when I looked at earlier. So just be aware of that.